Now let's look at a trig substitution problem. So before we do that, let's remind ourselves what the trig substitutions are. So if you have a square root of the form a squared minus x squared, then your trig substitution would be x is a sine theta. If you have an a squared plus x squared square root, it'll be x equals a tangent theta. And finally, if you have x squared minus a squared in your integral, your substitution would be a secant theta. So let's look at our first problem here. Let's evaluate the integral of x squared over the square root 9 minus x squared. So looking at the square root, which one of these does it match up with? It matches up with this first one, where a is 3. So our substitution should be x equals 3 sine theta. Dx will be 3 cosine theta. And now we're going to take our integral and swap out all the x's. There should be a dx here. Swap out all the x's for thetas. So you'll have taken square x, you'll get 9 sine squared over 9 minus 9 sine squared. And then swap out dx, which will be 3 cosine theta d theta. So if you simplify this square root, you're going to factor out a 9. It'll become 1 minus sine squared, which you can plug in. That's the same thing as cosine squared. So the denominator will simplify down to 3 cosine theta. So we're going to cancel out the 3 cosine thetas, and we're left with 9, which I'm going to go ahead and pull out. 9 sine squared. And now look at your power on sine. It is even. So that means we need to rely on our double angle formulas. You would get a 1/2. So I'll just go ahead and pull that out. 1 minus cosine of 2 theta. So then we can compute the integral. 9/2 theta minus sine of 2 theta over 2 plus c. Now remember, you've got to put your answer back into x. So to do this, you're going to have to go back to your substitution. What was our substitution here? It was x equals 3 sine theta. So if you solve for sine theta, it would be x over 3. And now we're going to draw our triangle corresponding to theta. Sine is opposite over hypotenuse. So this missing side length would be the square root of 9 minus x squared. Again, that square root matches our square root in our integral. And so we've got a little bit of a problem here because we don't have theta, we have 2 theta. So you're going to have to use the double angle formula for sine, which this is the same thing as 2 sine theta cosine theta. And the 2's will cancel. So I need to know what sine theta is. I already know that. It's x over 3. But I also need to know what is cosine of theta. And I need to know theta as well. So theta will be inverse sine or arc sine of x over 3. And then sine is x over 3. Cosine is the square root 9 minus x squared over 3 plus c. And there is our answer for this integral. So don't forget that you need to draw this triangle to switch back to your answer being in terms of x. So now let's look at a problem involving partial fractions. Let's evaluate the integral from 1 to 2, 3x squared plus 6x plus 3 over x squared plus 3x plus 2. So remember, we use partial fractions whenever we have a polynomial over a polynomial, i.e. when we have a rational function, which is exactly what we have here. But we've got a problem. The degree of your numerator needs to be smaller than the degree of your denominator, and right now they're equal, so you're going to have to divide these polynomials first. So let's go ahead and divide. So I gotta multiply x squared by 3 to get 3x squared. You'll get 9x and 6. And then we're gonna subtract these, so you'll end up with a negative 3x and a minus 3. So now my integral is the same thing as 3 plus my remainder plus 2. And so I know how to compute the integral of 3, but now we're going to focus in on this part, and we're going to use partial fractions for this. So factor the denominator. X squared plus 3x plus 2 factors into x plus 1 and x plus 2. And now we're going to set up our fractions. Negative 3x minus 3, x squared plus 3x plus 2. It's a over x plus 1, b over x plus 2. I guess we could leave the denominator in its factored form. So x plus 1, x plus 2, and then you multiply by the denominator on the left. So you'll get a, x plus 2, b, x plus 1, and we're going to plug in values of x. So if I plug in, if x is negative 2, you'll get 3 equals b times negative 1. So b is negative 3. And if you let x equal negative 1, you're going to get 0 for a. Now there is a reason why we're getting 0 here for a. If you look back at our original fraction, if I factor a negative 3 out of the top, and leave the denominator factored, you'll see that the x plus 1s cancel. And so that's why we're getting 0, is because we could have canceled something in the numerator and denominator. So now what am I left with? The integral from 1 to 2, we had 3 plus, our a was 0, so we just have negative 3 over x plus 2. So now we can compute this integral. It would be 3x, do a u substitution for that the second term, ln x plus 2, plug in top number minus bottom number. So you'll get 6 minus 3 ln of 4, minus 3 ln 3, which if you want to, you could simplify that as 3 minus 3 ln 4 plus 3 ln 3.